Hello everyone and welcome in today's video. Today I will model the previous question which we solved by hand calculations in Autodesk robot software, and in the end we are going to compare the results with the hand calculations and make sure that what we calculated by hand can be used in the future. So without any further ado, let's continue with modeling our task, and let's create a new model. We are yet on the 2D frame, but still this type of questions can be modeled also on 3D space or model. It would not matter that much. We just have to be careful how we would make the releases to make sure that it's going to be the same as in 2D. So the first step, as we always do, is to define a member. And if we go back to the task which we solved by hand in the end, it was assumed this type of profile for the beam, which had the following properties, and these are going to be the exact same properties which the software is going to have. And let's go back to the software. Okay, we already have this member here, and the next step to be done is to model our member, and according to the problem, it was mentioned that A is going to be 2.5 meters. Yes, so we have both of them are A's. So now let's start to model our member. So this is 0, 0. We have it at 2.5. We can also input these values manually, and then we add the value 0. So now we have our member here. As you can see on the bottom corner, we have the member length at 2.5 meters. And next, if someone wants to copy, a good thing can be done if we go to Tools, we go to Customize, and we press this option which says Show Toolbars, and we want the Edit toolbar to be shown, and we turn that on, and we can have the edit commands. So this one is going to be the one which is going to move or copy things. So now we want to copy, we press this one, and next, if we go to the model, we click select the members, and now if we want to copy this member, we just select the first node and the end node, which is going to be the beginning of the second member. So now we successfully modeled our beam, and the next step to be done in order for the structure to be stable is to add the support conditions. And according to the problem, we had a fixed connection here at point A, a roller here at point C, and an internal hinge at point B. So let's go to the support options and model the fixed support. And actually, according to the problem, this fixed support was actually rotated, but for these cases, it doesn't matter that much. It basically would be the same. But if one wants just to rotate the support, they can put these direction of the support at 90 degrees for this case, and then they can have this support at 90 degrees rotated. Next, let's add the roller here. If we select the roller, this is going to be the configuration for a roller. Let's just add the roller here at the last end. And now we successfully added the roller. Let's just show the node numbers. So at node number 2, we had an internal hinge. So now we have to make some kind of release between these two members. So next, we need to add the internal hinge. And how we do that is that we need to set off the releases for the members here at joint number 2 according to the software. So next we go to geometry, we go to releases, and to we need to define this release for joint number 2, so it's going to be free to rotate. And how we do that, for example, if we go to this fixed pin release, let's say that at the end member these are not ticked, as we already have the support condition here, but we want to release the rotation at this point or at this joint number 2, and we just select the node of our interest, which is going to be number 2. We see that it's already selected. Next, we select the member, and we must be really careful on how we are going to define which is going to be the end and the beginning. So basically, according to this one, we said that the end is going to be this side. As you can see, the arrows are indicating from joint or from node number 2 towards node number 1. As you can see, the arrows there. And this is going to be the beginning for us, and the end is going to be at node number 1. For example, if we hover the mouse at the left hand side, we can see that the arrows are going to indicate from the other side, which means that the beginning of the end is starting at node number 1 and ending at node number 2. So we must be really careful on how we select these members. So at the beginning we are going to have the release, and we select in this way. And now we successfully added our internal hinge here at joint 2. So the next thing to be done is to create a load case. We go here to the load types, we just add a dead load, and then we add a member load. So according to the problem, the load P here in the end, where was it? It was assumed to be 5 kilonewtons per meter. We just go to members and we select uniform load, and this value -3, let's just put it as -5, hit apply, and then we just select the members on which we want to apply the load. Then we click close, and if we want to see the loads, we can turn these two options on, and then we have the results. But also, I would just like to mention here, if one wants to see the releases, they can just go to the display properties here, or they can quickly press VV 2 times. As you can see here, if we go back and we just right click on the background, we can see that we have the shortcut, which is going to be VV command here. And next, if we go to favorites, and then we are going to have this option which says releases, and if one wants to see them, they can take this button on, and we can see that we have the release here. But also, if you want to show how or what is released or not, we can turn this on. With this axis mean that they are not free to move, but for F it means that it's free, which is the third coordinate, which is going to be the rotation, and as we want here at the hinge to not have any bending moments, which basically is free to rotate. So now we successfully modeled the beam, so now we hit calculate. We have the results available as we did on the previous case. Let's go to remove the dead load, or the self weight of the structure actually, because also the load which we added can be considered as a dead load. Now we go to start and we hit run again. And now we are interested on the displacement at this node number 2, which for our problem was node number B. We just go to results, diagram for members, and if we go to the deformation and we hit normalize, but let's go here and put these settings so we can see the value actually. We can see that the vertical displacements according to the software is going to be 66, which comes as the same value which we got from our hand calculations, and this shows that the value which we obtain parametrically by hand calculations can be used in the future for this type of beam. So thank you very much for your time. I really hope you enjoyed today's video. If there is any questions, please leave them down in the comment section below. See you on the next video.